Page 501, number 13. We are to use polar symmetry tests to determine if the graph is symmetrical and in what way. And we're supposed to support our algebraic solution with a grapher, so a graphing calculator. And our polar equation is r equals 3 plus 3 sine theta. Now we're going to do this backwards since we're just starting out. We're going to look at the graph first, see if we can determine the symmetry, and then verify it using one of our symmetry tests. So I graphed this one in the 84. The next example I will graph using the Inspire. And so what you can see is that when you look at this graph, it is symmetrical about the y-axis. So we have y-axis symmetry. So we're going to use the y-axis test to determine our symmetry. So using r equals 3 plus 3 sine theta, if we have y-axis symmetry, we can replace r with r comma theta. Pi minus theta. Pi minus theta. And that should give us the original graph back, the original equation back, so we can see that it is symmetrical. So replacing theta with pi minus theta, we're going to have r equals 3 plus 3 times the sine of theta minus, pi minus theta. And what you want to remember is that sine of pi minus theta is equal to sine of theta. That's one of our identities that we learned in chapter 5. So we get r equals 3 plus 3 sine theta. So we get the original equation back, which means that this does indeed have y-axis symmetry. And we also verified that on our graphing calculator. So we know for sure that this graph has y-axis symmetry.